Okay, so you have learned about relations. Now we're going to talk about something called a function. We're going to revisit the menu situation. We know that a menu is a representation of a set of ordered pairs or a relation. A menu also represents something called a function. So a menu is a relation, but a menu can also be a function. Here's an official definition of a function. A function is a special relation in which no two different ordered pairs have the same first element. So if we have a set of ordered pairs, a function says that they have no two different ordered pairs have the same first element or the same first value. In your ordered pairs, the first number in each ordered pair should all be different. It's basically what this is saying. And we'll take a look at what that looks like in a minute. Okay, so let's look back at our menu. Reminder, a function is a relation where no two different ordered pairs have the same first element. So if we go back to our menu, our first value, or we could say our X value, was the item. Our Y value was the price. So our first element was the item. Our second element was the price. If we look at our first pieces of information, are there any repeating? No. Hamburger $3.50, pizza $2, sandwich $4. So this could be considered a function because of my ordered pairs, the first sets of numbers, no two are the same. Here's an example of something that's not a function. Let's look at this menu. What does it look like when the first element repeats? Okay, so a function is a situation where none of the first pieces of information ever repeat. They're all unique. But let's take a look at what happens when they do repeat. So I have a hamburger for $3.50, pizza for $2, a sandwich $4, pizza $3. If I look at my first value, the first elements, the X coordinates, do you see pizza twice? If I go to the counter and I get charged $2 for pizza, and you go to the counter and you all of a sudden get charged $3 for the same pizza, are you going to be upset? I would hope so, because something's wrong. It's not like it says pizza and then pepperoni pizza. It says pizza and pizza. That's a problem. If a business ran themselves like this, they'd be out of business. You can't do that. You can't charge $2 and then $3 for the same thing. This would not be a function because something in one of the first elements repeats. That creates a situation that doesn't make sense for what we're working with. So that's what it looks like when the first element repeats. That would be considered not a function. Okay. Let's take a look at what happens when the second number repeats. Okay, so in this case, my first elements, my X values, domain, input, however you want to call those, nothing repeats. Everything's the same. If we look at our Y, or our second element, our output, I have my number repeating here. So let's see if that could possibly make sense. Could I have prices repeat? We already realized I can't have menu items repeating with different prices, but can I have prices repeating with different items? Let's see if this makes sense. Hamburger, $3.50, a pizza is $2, and tacos are $2. Is it possible that pizza could cost the same as tacos? Sure, there's no law saying it can't. Okay, nobody's getting ripped off. Two people aren't getting charged different for the same thing. So if the second number repeats, it is not a problem. Remember, we focus on the first set of numbers. These first set of numbers have nothing repeating, so this would be a function. So when you're looking and trying to decide if something is a function or not, you can always think back to the menu. If the first values repeated and the second values were different, there's something wrong there. That means you're getting charged different for the same item. Okay, so that may be something that helps you kind of remember as we work through. So, yes, we looked at a menu. That's amazing. But I do need to give you a list of a better way of how to tell if something is a function or not. Because if you remember back to the relations, there are 4 ways to show relations: a table, a list of values, a graph, and the mapping. So depending on what everything looks like, I'm going to talk you through how to tell if it's a function or not. Okay, so our first thing we're going to look at are lists and tables. So number 1, lists and tables. So if you're given a list of numbers or a table, 2 things you're going to do. First thing, you're going to focus on the x coordinates or the input. So those are the only numbers you're going to look at. If it's a function, none of the x coordinates will repeat. Okay, so these 2 things will help you decide if a list of points or a table of inputs and outputs, if it makes a function or not. We're going to practice this, but for now, get this information down. Number 2, a mapping diagram. So if you're given a mapping diagram, and if you forgot what that was, we'll do some examples in a second. If you have a mapping diagram, how are you going to decide if the relation is a function? Just like the list and the table, we're going to focus on the first set of numbers. Okay, remember, a relation says that there are no numbers repeating in the first element. Okay, the first x coordinate, the inputs. So focus on the inputs. Each domain or input will point to only one output. This is our way of seeing if there are any repeating inputs or x values. So each domain will point to only one output. Number 3, graphs. So if you have a graph, you might have points that are graphed. You might have a line that's graphed, a curve. So you're given some sort of graph. How can you tell if the relation is a function? Okay, you might be able to tell by just looking. If you have points, you might be able to just visually look and see none of the x coordinates will repeat. This is a little tricky because depending on what it looks like, you may have a bunch of x coordinates to check. So sometimes it's harder than others. So the second thing you can do is to complete something called the vertical line test. And we're going to talk more about that in a second. The vertical line test is the perfect way to check if a graph is a function. Much easier than checking x coordinates repeating by just looking. Okay, the vertical line test. So the vertical line test is a little test that you can run on a graph to decide if it's a function or not. So we have 3 steps. Step 1. Actually, it's not quite steps. It's 3 pieces of information. Number 1, this is used to determine if a graph represents a function. So the vertical line test is something you do to see if a graph is a function. So that's the first thing you need to know. Number 2 starts getting into how to do the test. Try to draw a vertical line through the graph so it intersects the graph in more than one point. So what you'll do if you have a graph of points or of a line, you're going to draw vertical lines and see, is there any point in this graph that I could draw a vertical line and hit 2 points or more? Okay, so again, and you'll see, we'll do a couple of these, but you'll look and you'll try and you'll say, can I draw a vertical line that will hit 2 points anywhere on this graph? And that brings us to 3. If it never intersects more than 1 point, that means it is a function. It passed the test, it's a function. Now, if you can draw a line and hit more than 1 point, it fails and is not a function. This is something that you'll hear a lot throughout high school, the vertical line test. And again, we're going to take a look at examples of each of these 3 things. All right, let's get into some practice. Determine if the relation is a function. How do you know? So we have a list of numbers. So go back and look at the section that says, how do I tell? How do you tell if a list is a function? So let's review. How do you tell if a list is a function? Well, if a list is a function, we focus on the x coordinates. If it's a function, none of the x coordinates will repeat. So that's what we're looking for. So we're going to focus on our x coordinates. Do any of these numbers repeat? No, these numbers do not repeat. So that means, yes, it is a function. And you don't have to write a whole sentence here. You can just say is a function. That's acceptable. How do we know? We know because no x coordinates repeat. It does not matter if the y coordinates repeat. We don't even look at the y coordinates for functions. All we want to look at are the x coordinates. So I want you to try this one. Okay. Hopefully you said not a function. If we focus on the x coordinates, do you see how I have -1 and -1 again? That tells me it's not a function. X coordinates repeat. That's why. It is not a function because X coordinates repeat. You can't have repeating X coordinates. Again, this is like saying the number -1 belongs to 3, but the number -1 belongs to -1. My X value can't belong to two different Y values and be a function. You could have any points you want ever, but if we're trying to decide if something is a function or not, you cannot have X's repeat. Now let's look at a table of values. The same rules apply as a list. We focus on our X coordinates and we decide, do any of these repeat? Do we have any that repeat? No, they are all unique. If none repeat, if it's all unique X coordinates, it is a function. Because no X coordinates repeat. Let's look at another one. Okay, our table is set up a little bit differently, but we still focus on the inputs. So look at those inputs and decide, is it a function or not? I want you to answer on your paper and then tell me how you know. Okay, so if we take a look at our inputs, I have a repeater here. Not a function. Because X coordinates repeat. Let's look at the mapping diagrams. So if we look back at how to determine a mapping diagram, whether it's a function or not, say focus on the domain or input values. That's the first group. Each domain or input will point to only one output. So let's see what that looks like. So these are our first elements, and the first element cannot repeat. So what's happening is with the mapping, it's saying 0 belongs with 3. So if I were to write an ordered pair, it would be 0, 3. This ordered pair would be 1, 1. This ordered pair would be 3, 1. This ordered pair would be 4, 2. Now, you do not have to write the ordered pairs down every time. You can. You don't have to. If I look here, my first element, do I have any numbers repeating? No. That means this is a function. I have no repeating X coordinates. For there to be no repeating X coordinates, what you're going to have is you're going to have one arrow coming from each of my inputs or my domains. Just one arrow. If you have 2 arrows, that means you're going to have duplicates. Here's what I mean. We're going to look at the next one. So finish this and then we'll move on. Okay, so let's look at the second example. We focus on our first set of numbers, our inputs or our domains. And I want to say, if it's a function, there's only one arrow coming from each of my inputs. But if you notice here, there are 2 arrows. So with my -1, I have 2 arrows. That's a problem. That automatically tells me it is not a function. The only thing is you may not remember, is it 2 arrows coming from the 1, or is it 2 arrows on the other side? You may get confused about what part can't have 2 arrows. So if you get confused, write the ordered pairs down. This first arrow up top, this first arrow means -1 maps to -1, which means I have an ordered pair -1, -1. This second arrow, the second arrow says -1 also maps to 3. 0 maps to 2, and 1 with 4. They're my ordered pairs. And if you look, see this? That's a problem. I cannot have repeaters here. That makes it not a function. Okay, so when you have 2 arrows coming off of one of your domains, not a function. Okay, so the last type of relation that we want to look at to decide if it's a function is a graph. So sometimes you have points, sometimes you have a line or something that's curved, and you have to decide, is it a function? So let's take a look at our list again. How can you tell if it's a function with a graph? So the first thing you can look at is see if none of the x-coordinates repeat. That's pretty common. In each of the different representations, we've looked at the first piece of information, the x-coordinate, the domain, the input, the first element. The first piece of the information is what we focused on. We can do that on a graph. If it's too hard to do that, we can complete what's called the vertical line test. So let's look and see how that works here. So the first method is to double check your x-coordinates and just make sure there are none that repeat. Okay, so if I look at my first point here, the x-coordinate is 0. This point, the x-coordinate is 1. For this point, the x-coordinate is 3. And for this point, the x-coordinate is 4. None of my x-coordinates repeated. I had a 0, a 1, a 3, and a 4. Now that could be a lot to remember, depending on how many points. You could write ordered pairs. Okay, so you could write the ordered pairs if you want. But again, that could take a lot of time too. So that's where the vertical line test actually becomes the thing that you can do that's the most efficient way of finding out if a graph is a function. So with the vertical line test, what we're going to do is you're going to see, can you draw a vertical line through more than one point? If you can't draw a line through more than one point, that means none of the x-coordinates repeat, which means it is a function. So just a reminder, a vertical line goes straight up and down. It doesn't curve, it doesn't bend, it doesn't tilt. It's a straight up and down line, even though mine doesn't look like one. Let me fix that for a second here. Okay, so I'm going to draw some vertical lines. There's a vertical line. Oops. There's another vertical line. Now you don't have to draw vertical lines through every point. I'm doing this so that you can see what's going to happen. And mine aren't perfectly straight, but you'll get the point. So if I look at these vertical lines, none of them are going to go through 2 points at once. What that means is I do not have any x-coordinates that repeat. That means all of my x-coordinates are unique. So it is a function. No x-coordinates repeat. That's what the vertical line test does. It's just looking for repeated x-coordinates. Because trying to count out the x-coordinates and trying to remember the x-coordinates and then think, did I have repeating ones? I don't remember. That vertical line test helps you find repeating x-coordinates quickly. Let's look at the other example. Now, we could go through and write ordered pairs. I could count, look at my x-coordinates and count and see if I have any that repeat. This point right here has an x-coordinate of -1. This has an x-coordinate of 0. This has an x-coordinate of 1. This has an x-coordinate of -1. And I can look here and see, they have the same x-coordinate, not a function. Or we can do that vertical line test and see how much faster this is. So I can go, what you're looking for is, can I make a vertical line that goes through 2 points? You don't have to make a line through every point. Look at your graph. It's kind of like giving yourself a challenge. Can I draw a line through 2 points with 1 line, vertical? Can I do that? Is there a spot on this graph where if I draw a vertical line, it'll hit more than 1 point? Hopefully, as you're looking, you say, oh, right here, I make a vertical line here and I will hit 2 points. If I can hit 2 points with a line, that means it's not a function. If my vertical line hits 2 points, that means I have a repeated x-coordinate. So that makes it not a function. And that's it.